This video I'm gonna talk about my thought experiment. It's my own thoughts. Well, this experiment is related to physics. I'm gonna prove that light behaves as particle and waves. Okay, so the experiment goes like this. Imagine that you have a pencil, and this pencil acts as a torchlight, and this is the part that will line up, and this is the back. So this is just an ordinary torchlight. So the place that you're gonna be in is the cosmic universe. Somewhere in the cosmic universe, it's a blank, it's black, it's dark. Why? Because there's no light, there's no earth, there's no planet. Just imagine nothingness. You're floating in the outer space. So when you open your eye, it's no difference between your closing your eye. It's the same. So what's gonna happen is that you have the torchlight in your hand and you open it. What will happen? Before that, right? Before you open, we make the assumption that the the front part of the torchlight here, you create a box, so a rectangle. It's going like this. So if you're holding like this in the angle, right, you can't actually see the front part of the torchlight because we make the assumption of we make a rectangle cardboard here. So when you open the light, right, when you open you function the torchlight, we were able to see the light. Okay, this is the question. Imagine the experiment goes like this, and you open the torchlight. Were you able to see the light? In this angle, obviously no, but when you adjust the angle, when you put lower down, or you move out your top a bit, yeah, so we are able to see. Well, there's your answers might say yes, but okay, what's the reasons you say yes? Because the only reason that you're able to say yes with the knowledge of physics, because this light behave as wave. How the heck is behaving wave? It's impossible. Well, remember, the surrounding that you're at is the cosmic universe. There's nothing, which means light cannot be reflected back to your eye, which means in theoretically, you cannot see the light even though you adjust. But if you adjust like this, obviously, yeah, because you're pointing to yourself, because you're pointing towards front of the direction of you, and you're putting the cardboard, so the is perpendicular to the torchlight and the cardboard. So light can be only seen if the person is standing perpendicular or at the angle of the front of the torchlight. So if you can see the torchlight at the back of the torch, I mean, you can see the light at the back of the torchlight. The only reason is because light behave as a wave, is sending the wave behind and front 360 degree. So if you're saying that you can see the light, that's the only reason. And if you say you cannot see the light, well, that's logic too, because light can be behave as particle. If you realize that um even though you put your head to the top, move your head to the top, and you adjust the angle lowering down the torchlight, if you see no light, that's because light behave as particle. Particle needs to reflect back to the camera, which is in your eye. The only reason that you're seeing this video, that you're watching the video, right, is because light from my angle here is reflecting to the camera here. Same goes to your eye. Light behave as particle needs to reflect back to your eye in order to see it, because the environment is cosmic universe, nothingness. So it's impossible to you to see the light that's moving to the direction. Okay, so this proves that light behaves as particle and a wave. But this experiment is not realistic because it's impossible to conduct this experiment. Can you imagine a place, nothingness, darkness, nothing? literally nothing. Well, it's impossible because if you were the astronaut at the cosmic universe, there's some planet exists, there's anything exists in the cosmic universe, so they will reflect back the light, but it takes very long because light needs to travel that long. So if you think like if you think this thought experiment is kind of cool, drop a like or something.